Hey everyone, and how's it going? Welcome back to day 2 of trigonometry. So yesterday we started talking about SOHCAHTOA and right angle triangles. So SOHCAHTOA being sine, cos, tan, and then which sides of the triangle are used when calculating that particular angle. So SOH, S-O-H, is opposite and hypotenuse. CA, C-A-H, use the adjacent and hypotenuse. And then tan, TOA, is going to be the opposite and the adjacent. So the first letter is the numerator, second letter is the denominator. So for TOA, tan, opposite over adjacent. Today, we're going to look at pretty much the focus for today is simplest radical form. So we're going to look now at how do we answer questions that we've been kind of seeing in geometry so far, but in a much more accurate way. So particularly with trigonometry, most of our answers would be in radical form if we were to just straightforward calculate them, which means we have to round them, and I'm sorry, I meant irrational form, but which means we have to round them essentially to be able to write our answer. So a way around that is to keep your answer in what's called simplest radical form. And we're going to look at that today and see how do we do that, and then kind of apply that to some of our trig problems already. And then there's what's called the special right triangles. These are the most common ones that come up. And there's some different aspects of that I want to show you as well. Questions for today. What are the relationships between sine, cos, and tan? So, how do they interact with each other? What can we do with that? The value of special right triangles. So can you recall them? This is one of those few times where I'm going to ask you to try and come up with a strategy for memorizing something, so kind of like a formula. And then how do you convert between sine, cos, tan is the other one. Okay, so here's our triangle. And using the rules for sine, cos, tan, I want you to complete the table. So thinking about this, if we were thinking about sine, cos, tan, that's SOHCAHTOA. Now this is going to be like almost like a formula that's generic. What would sine of angle A look like from the triangle above? So angle A up here, that would make little a the opposite, little b the adjacent, and lowercase c is the hypotenuse. So sine of angle A would be opposite over hypotenuse, so that would be lowercase a over c. Make sense? Cos of angle A would be adjacent over hypotenuse, so that would be lowercase b over c. And tan of angle A will be the opposite, which is lowercase a, over the adjacent, which is lowercase b. Notice that, I don't know if I pointed this out before, but lowercase a is opposite corner A or point A. And that's the way you should be setting up your triangles. So the lowercase letter should be opposite the points with the same letter, if they're going to have the same letter. All right, so then flipping over to angle B. So from the point of view of angle B, little b is now the opposite, and little a is now the adjacent, and c is still the hypotenuse. So sine of angle B, opposite, so that's lowercase b, over adjacent, or sorry, over hypotenuse, so that'll be b over c. Cos of angle B is the adjacent side, a, over the hypotenuse, c. And then tan of angle B will be b over a. What are you guys noticing? So hopefully, like, one thing you're noticing is that a over c and a over c is repeated. So if we were to look at that, that would be sine of a gives you the exact same answer as cos of b. And the reason is they use the same side. So using little a over little c. Same thing with sine A and cos B, or sorry, sine B and cos A. So sine B is equal to cos A. And then with the tan ones, they're actually the inverse of each other. So tan of A would be 1 over tan of B. So that's how you would get it to invert. So those are some rules that I want you to pay attention to, because we're gonna see this come up. And this is a very common multiple choice question, like which of the following equivalency statements are true? And that would be the sine of one acute angle is equal to the cos of the other. That's the kind of generic rule. All right, so our generic rule, sine A equals cos B, sine B equals cos A, and then the tan ones are inverted. So just kind of remembering that when you get one of these right angle triangles, the sine of one angle will equal cos of the other. That's pretty much what you need to get. We don't see the tan part come up too much, but worth noting. Okay, so we're going to now look at converting into simplest radical form. So a radical is just any number that has a square root in it. And the way to convert it to simplest radical form is we're going to try and take the largest possible whole number out of it and then leave behind the simplest radical. So that is a radical that could not be simplified any further. One thing we're going to need for this is square numbers. Now, if you're not familiar, a square number is any number, so basically it's the area of a square. So if I have side lengths of 1, the area will be 1. If I had side lengths of 2, the area would be 4. So basically you could take any number, so this would be 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, you get the idea. And the answer is a square number. So you need to know your square numbers because you're going to need to be able to recognize which square number is going to be the largest factor. So I would recommend writing these down in your notebook somewhere, making a poster out of it, memorizing whatever you need to do. Like if you don't know your times tables up to at least 144, even 169, I would try and get yourself up to 225 that you know all your square numbers. So that would be 15 squared. So all the way up to 15 squared, you should know those numbers and then be able to recognize them. It'll make life a lot easier for you than having to test every single one. All right, so let's just do an example and let me show you what I'm talking about. Square root of 75. If you plug that in your calculator, you're not going to get a whole number answer because it's not a square number. So we want to try and break this down into simplest radical form. What we're going to do is we're going to look at what are the factors of 75. So thinking back to Algebra 1, factors. Those are numbers that multiply where the answer is 75. So the product of two numbers is 75. So example, 1 times 75, 3 and 25, 5 and 15. So then we say, all right, which of these is a square number? So we got 1 and 25. 25 is the greatest square number, so that's the one we're going to use for this purpose. So that means that we're going to say, all right, 3 and 25 are my factor pair, and I need to use those two. So the square root of 75, and this is the kind of the cool part, that you can break the square root up into its factors as long as they're both still within square root, so still radical numbers. So root 75 is the same as root 25 times root 3. And hopefully in law of exponents in Algebra 1, you got a reason for why that's true. If not, you will see it again in Algebra 2 where you kind of go into more detail as to why that's true. So then square root of 25 is just 5, and then you still got the square root of 3, so it's 5 times square root of 3, or the way we would say it is 5 root 3. So this would be 5 root 3. You could also say 5 times the square root of 3. You're not going to be wrong. Whole number will go first, and then the radical. That would be the grammatically correct way of writing it. Okay, so your turn on these. Pause the video, take a shot at it, see can you convert each of these to simplest radical form. Note if there are no square numbers that are factors of any of these, then the number itself is in simplest radical form. All right, let's take a shot at it. All right, let's see how you did. So the first one, 6 root 2. Now where do we get that? That would be root 36 times root 2. So 36 times 2 is 72, and then the square root of 36 is 6. Second one, 4 times root 5, so that will be root 16 times root 5. Those are my factors, and square root of 16 is 4. And then 16 times 5, 80. So hopefully you guys are seeing the pattern here. 63, you spot it. 3 times 7, so we know 9 times 7 is 63. 9 is a square number, so 9 times root 9 times root 7. Square root of 9 simplifies to be 3, so we get 3 root 7. 180, it's going to be 36 times 5, so root 36 times root 5, which is 6 root 5. And then square root of 101, what'd you guys get? It's actually square root of 101. There's no square number that is a factor of 101, so 101 is in simplest radical form. All right, so now you're like, well, why is that important? Let's pause for a second. I need to do another kind of background part. So if cos B equals 4 over 5, sine A is what? A very common question to get. Remember from a couple of slides ago, sine of one angle equals cos of the other angle. So it's B and A, and they are both the acute angles in the triangle. So, very easily, we're just going to say they're the same. So sine A is 4/5 too. So that's a very quick conversion we can do between cos and sine. If sine of an angle is a half, what would cos of the angle be? And write your answer as a fraction again. This is where we're going to start seeing the simple radical form pop up. So we got two options. We can solve for the angles. Remember, we know if sine A equals a half, we could then figure out angle A by using sine inverse of a half is equal to angle A. So we can use the inverse function to find that. And then once we know the angle, we could then say, what's cos B? The problem is our calculator is not going to spit us out a fraction every single time, especially if there is a radical number involved. So it's harder to get a fraction form for that. The second option is going to be to draw a quick triangle out and then use Pythagoras' theorem in simplest radical form to find the missing answer. And this is Pythagoras' theorem is going to be a big part of using simplest radical form. All right, so let's try it out. If sine theta is a half, what is the value of cos theta? Write your answer in the form of A over B. All right, so we do the sine inverse of a half, we get 30 degrees. This is that first option, so figure out the angle. So then we'd want to figure out what is cos of 30 degrees. It's an irrational number, so getting it into fraction form, not possible in this case. So then, all right, so in option 2, we got our triangle. We fill in the sides we know. So if theta is down here, opposite is 1, hypotenuse is 2, and then we're going to solve for x. So you know two of the sides, and remember it's not the hypotenuse, so it's going to be 2 is going out here in the C position. It doesn't matter where you put 1 in the A spot or the B spot, you'll get the same answer either way. So we get x squared is 3 and square root of 3. Square root of 3 is in simplest radical form, so we're done. So that means this is root 3. And cos of that angle is adjacent over hypotenuse, so we get that root 3 over 2. All right, your turn, guys. If sine of theta is 3/5, what is the value of cos theta? So I would go straight for option 2, to be honest here, guys. Just get in that habit, use simplest radical form. That's really the goal for today. And see, can you solve it? Question 2, different way of asking it. Triangle ABC, C is 90 degrees, cos of A is 6/7. What is sine of angle B? And then you got tan of D, what's tan of E? And then XYZ, X is 5/13. What is tan? So converting between sine and tan this time. Take a shot at it. Let's see how you did. All right, let's take a look at those answers. All right, cos theta, 4/5. So if we've got a triangle, I'm just going to place theta down here, and sine is opposite over hypotenuse. So there's my 3 and my 5. So you do 3 squared plus, we'll call it missing side squared, equals 5 squared. So 9 plus x squared equals 25. X squared equals 16. So x is 4. So then cos of the angle would be 4 over 5. So that's where that comes from. Second one. Did you recognize that you had cos of one angle, sine of the other angle? So really they are the exact same thing. You didn't have to do any work there. You could put it on a diagram and check, but you would have gotten the same answer, 6/7. Rule for tan. So remember, tan of one angle, tan of the other. So tan E will be equal to 1 over tan D. So our answer should be 2, which is, I'm kind of in the way of it though. But again, you could put it on your triangle in C. So you would say F is the 90-degree angle. We got D and E. So tan of D opposite over adjacent, tan of E opposite over adjacent. So that's where that 2 comes from. And then question 4, you should have gotten 12/5. So we got our triangle, X, Y, Z, and we were given sine of X is 5/13. If you do Pythagoras' theorem, remember we have the hypotenuse, so you're solving for one of the other sides, you get 12, and then tan of Y will be opposite over adjacent, so that 12/5. All right, just some language to throw in here that'll help you with the Khan Academy questions as well as some other word problems that'll come up. It's angle of depression versus angle of elevation. It's just a way of describing the direction of an angle. So angles of depression go downwards, angles of elevation go upwards, and key, and I'm going to underline, I'm going to circle it, like it's to a horizontal line. So in our case down here, this is a 40-degree angle of depression. So it's going down from a horizontal line, whereas the vertical angle to it would be an angle of elevation if we were using that. This is an angle of elevation. It's going up compared to a horizontal line. The vertical angle would be an angle of depression if it were being used or talked about. Okay, so let's take a look at an example. John's looking out a window 30 feet up from the ground. He sees Nadia, who's in a building 20 feet away, and sees her at a 35-degree angle of elevation. How high is Nadia from the ground? Take a second, try and sketch the situation out. What does it look like? All right, let's see how you did. So you got your buildings. Say there's John, there's Nadia. He's 30 feet off the ground. They're 20 feet apart. It's a 35-degree angle of elevation, and we want to figure out how high she is from the ground. Now, X is not our answer, because we want to know how high she is from the ground. X is simply the difference of their heights, and then we're going to add 30 to it to get our answer. So if we were trying to solve this, we got our angle down here. X is the opposite. We're given the adjacent. What type of problem is this? It's a tan problem. So we'd say tan 35 degrees is equal to X over 20. Solve for X, multiply by 20 on both sides. So 20 times tan 35 is going to be our solution. And that is 14.004. So it's the nearest foot. It's going to be 14 feet is equal to X. The final answer, Nadia, is 30 plus that 14. So Nadia is 44 feet off the ground. Big mistake people make is to not actually solve the problem they were asked to. They find X, they get excited, and they forget about the rest of it. So just keep an eye out for that. All right, so in your notes, create a table like this one. So it's got 30, 45, and 60 degrees on the left, on the first column, and then sine, cos, tan across the top. I'm going to ask you guys to actually complete this table using these. Okay, so let's take a look at a special right triangle, which we're going to use to figure out that table. What I'd like you to do here is find the value of X and then also theta. And then also when you find that angle, which you'll see what I'm talking about in a second, I want you to fill out the table. And use Pythagoras' theorem to find Y. That will also help us in a couple minutes. All right, take a shot at it. All right, so solve for theta. We know the opposite, we know the adjacent, so that's a quick one for us. Tan theta is equal to 1 over 1. We want to get the angle, so we're going to say the angle is the tan inverse of 1 over 1, and you get 45 degrees is theta. So this is a 45-degree angle. This one must also be 45 degrees because it's isosceles and 90, so you could subtract and get your angle sum theorem. All right, and then the other one was to solve for the value of X. So 1 squared plus 1 squared equals X squared. 1 plus 1 is 2. So square root of 2 is X. And then let's see. So if this is 45 degrees, this is 90, that means this must be 45 degrees, and same on this side. So basically now you've got 45-degree angle, the adjacent is y, the hypotenuse is 1, so that will be a cos function. So cos of 45 degrees, or sorry, not cos, yeah, cos 45 degrees is y over 1, multiplied by 1 on both sides. So that's kind of a pointless one, but cos 45 degrees is going to be, let's put that in our calculator quick. Cos 45 is 0.707. That is a terrible zero. 0.707. I really apologize for how ugly that looks. The y part is not super essential here, guys. What I want you to do is complete your table for a 45-degree angle. So remember on a previous line, we had 45 degrees and then sine cos tan. So here's your 45-degree angle. Sine 1 over root 2. So 1 over root 2. Cos, also 1 over root 2. And then tan, 1 over 1. Make sense? Cool. Okay, repeat the process this time, finding the value of theta and then also for x, and then complete the table. So you should get x is root 3, and then theta is 60 degrees, so you should be able to complete the table using that information. So here's your completed table. You can ignore the page 716, 719. I'm actually going to give you some Khan Academy stuff to work on instead. Start from now on trying to answer questions using simplest radical. So relationship, we know sine of one angle is equal to cos of the other acute angle in a triangle. The tan angles are the inverse of each other. Special right triangles, those are the ones with 30, 60, and 45-degree angles. So we should be able to recall what sine, cos, and tan of each of those angles are from that table. It will help you with solving other questions. For tonight and rest of the week, I'm going to give you some Khan Academy to work on, and I'm going to post some extra practice worksheets as well. Those are optional to do, but if you're like, I would just want to practice on these, which is really what you need to do, these are what I would do. All right, I'll talk to you guys soon.